Okay, doke. I have nothing? I've never... Okay. Fuck. I don't have... Alright, well, GG's. Oh, wait, here we go. Alright, so through 11.9. Alright, cool. Pop. Big old quiz, yo. That took way too fast. Wait, what? Oh my. Go, go, go. Alright. We've got some stuff. I want a song to go with it real quick. And it's going to be... What is it? That... Cool. Can't hear it? Good. Alright, let's go. Already processing? We're good. Let's get this going. Please. Right there. There we go. Took too long. Okay. Alright, we're gonna work backwards. Okay. So we'll do 69. Non-type template parameters are template parameters defined in the template clause preceding a function that have a specific type and expect and must receive a const expression value of that type. The use case is to pass const to effectively make const expression function parameters, which normally are disallowed. I.e., if I have a const expression value I want to pass to a function most optimally, well, a function and check its value, and for errors and check for errors at compile time, the static assert then the function needs to somehow receive the const expression value at compile time, which isn't possible via a function parameter, so we accomplish this via a non-type template parameter. 68. Function templates are generic code that generates a specialization and overload version of itself. Same logic, but parameters that match the calls to the function template in code. We can explicitly call specifics specializations, or let type template or template argument deduction determine the types of the arguments and make a specialization using them as is. They help us reduce error chance and streamline identical functions that take different data types, calling one primary template that instantiates specializations as needed via the calls. Okay? If two overloads are ambiguous, we get a compile error, because the same step to resolve the non-exact match, the arguments, or well, compiler doesn't know which overload to call. Maybe two overloads have identical signatures, or maybe two overloads are unique, but the implicit conversion step to get or to get a closer match to one overload or to overload would make two plus overload would make multiple overloads callable. So the compiler wouldn't know which to call. So same shit basically, but just after a conversion. Function overloading is having multiple versions of the same function identifier, where the compiler determines which version is called depending on which version most closely matches the call's arguments. Type aliases let us use existing data types using user-defined names. Same for type defs. Example: using double as thing. Oh, or is it using thing as double? Hold on. Oh, and then instead it's type defining double as thing. Or is it not an equal sign? I don't remember. Oh, type def double thing. Thing as double, or type def double thing. The auto keyword can either serve as template type or template parameters in functions, If we had an auto guy, and then we called it with different shit, it would generate a specialization depending on the guy. As a shortcut for template parameters. So a specialization is generated. It's created for each unique combination of argument data types that call the function. Or it's regular type deduction, where the data type matches the object's initializer. Can also be used for trailing type signature, trailing return types, like auto do thing double. Make do thing return a double with a shorter name. More helpful for longer types, like standard common type T, type name A, or T, type name U. 63. Implicit type conversion is when we call a is when we call a function or is when we pass data of one type to something expecting another type, which converts our start data type to the target data type. It can get compiler errors, warnings, depending on the type of conversion, if it's value preserving or not, etc. 62, okay. Invalid user input can be handled with standard character input, using standard character input UF to check if the, using if standard character input, standard character input, check if the last standard character input operation was successful, and if it wasn't, we can use standard character input dot clear to reset standard character input so the next operation won't automatically fail, as it would have if we didn't unflag clear it. Then standard character input dot ignore to clear the invalid input before. Then if standard character input dot UF to check if the the entered character was an UF character, which would disconnect the input buffer, making us and we'd abort the program to reconnect, since the since the user would enter an UF character to end the program, or if not an UF character, we could use this to clear the invalid but not UF character. This works for value overloads too, like passing a too large int into the input buffer, like extracting a too large int to okay. 61 assert from the C assert header file checks its condition at runtime and calls standard abort if the condition is false. We can check for impossibilities or expected bugs with this. Like if when applying damage to a character, I might assert that the damage is greater than or equal, that is greater than or equal to 0, because we shouldn't be doing negative damage. Logical operator and operator and to append, a C style string to that condition, which evaluates to Boolean true after conversion, thus not affecting the condition result, to better explain the assert error if it once the compiler generates the error. 60. Code coverage is the percent of code a unit test runs. Unit test runs. The higher the percent, the more code we've tested and the more cases we've handled. More importantly, is getting 100% code coverage and 100% branch coverage. So we test all possible, as many cases and possibilities as possible. Makes sense. So like we can have a bunch of shit. If we do damage that's above this, it plays this huge animation for the character. If we do this much damage, it does this animation instead. It's like it's like huge damage, boom, the guy flies way back and it plays that animation. If we do medium damage, he goes, not quite as much. And if we do a little bit, he just goes, and if we do no damage, it doesn't hit him, it misses. And I can run a test that calls that function with this value, and with this value, and with this value, and with this value. And then I can have a branch, and it's, and we could just say, well, I guess it would be a switch case. It would be a switch case, and it would say, no. We would do an if else, or if, else. So we do if, take damage, else if, medium damage, else if, this damage, or we could just say, to catch it faster, we could do if negative, boom, do this, else if slightly positive, not a lot of damage, do this, else if medium damage, else if larger damage, else huge damage. That way we already cover all 0 and negative, or negative, and then 0, and then the extra shit. And we run one unit test, one function that calls it at these different values to test each possible branch. We test all the different code and all the possibilities. That way we have the most reliable unit test. This makes our unit test more reliable. And lets us catch more random more errors and validate input. And identify input, we need to validate something like that. 59. I would use standard chrono steady clock and standard random device to initialize a standard seed sequence, which I use to initialize a Mersenne twister MT1937, standard MT1937. Called via identifier from a uniform int distribution to get the random number in a specific range. Break exits the innermost loop and continues after. I'll just say sure. Oops, that should be 58. 7. Fall through is when we don't return or break after statements and after a switch cases statement. Then executes or subsequent statements, even in subsequent cases, it's executed despite our switched value not satisfying that case. Done for now, so I have time to review your feedback. Cool. Okay. What do you think overall? Huh? Uh-oh. Motherfucker. God damn. Switch fall through, sure. Bro. This isn't true. If I return, it fucking leaves, yo. Hello? Bro, that's just straight up wrong. If I have a function and I pass it a value, and inside of it is a switch case, and in that switch case, we return, or whatever, I call a function, and it is a switch case, and depending on that case, it evaluates code, or it executes code, and I have fall through happening, I don't break or return out, it's gonna execute the next shit. If I don't break, and I don't return, which would immediately return from the function, okay, you're just wrong. I mean, I'll check it, let's find out. Well, I don't have time. Break exits the innermost loop. Yeah, we know that this happens for all loops and switch cases. Yeah, it's fine. Oh, well, I guess I should have said that too. Like, that it exits switch cases too. I didn't. It's not just the innermost loop. It's the innermost like condition structure thing, something like that. Current, sure. Is usually sufficient. Okay, so basically, well, I mean, I said exactly what I was going to do. Yeah, it's exactly what I said. All possible values or edge cases. Well, yeah, we have to do branch coverage, sure. 100%. Yeah, sure, not all scenarios, but we're testing if all branches have been executed and if all code has been executed. And sure, we're not testing every literal possible value, but we're testing all the possible conditions that we've got. That's it. That's all we've got. True, false, true, false, true, false. So we test true, false, false. We test true, true, true. Test false, true, true, etc. Okay, nothing of note so far. What? Yeah, that's just wrong. We totally can. Alright, well, why didn't mean overload? Okay, I meant to type overflow, but I'm tired. Well, yeah, I'm not gonna put the whole fucking numeric limit, standard stream size, all the way up to an inline character. Okay. I guess it is warnings then, huh? Alright, so implicit conversion is fine, it's just that we get warnings. Okay. And it's automatic conversion, sure. Auto is not used for template parameters in function templates. Well, yeah. You just said, what's the auto keyword, motherfucker? Yeah, it's type deduction. We know this. And lambdas? Yeah, that's exactly what I was saying it for, okay? I disagree with this. Improving readability, then I have to go and fucking read code to figure out what it actually is. Fuck off. Function overloading. Yeah, sure, yeah, different count of the parameters or different type parameters. Yeah, we know this. Unique signatures, sure. Oh, yeah, I guess so. I guess it wouldn't be ambiguous. You would just get a compiler error for, hey, a redefinition of the same. Like if we did. Art of the body. Okay. Equally good matches. Yeah. Makes sense. Yeah, we do a call and it doesn't know hair. Are we converting this character to a short or are we doing this character to a long? Well, it's numeric conversion for both, not promotion. So it generates an instantiation with that shit and the specialization. Oh, so the specialization is literally the explicit version. So it doesn't instantiate a specialization. Well, then what is it instantiating? It's instantiating. Oh, it instantiates a version. I'm using them interchangeably, bro. There's an explicit specialization. I've seen explicit specialization as a word. I'm saying that. It's fine. Yeah, but the end result is that we get functions that have different signatures. So, I mean, we get would do thing, right? And then we get, sure, it's like int, whatever, and then it's int, okay? Versus void do thing double, oops, double, oops, double, double. Template, template, type template, type name T, void do thing TX. See, we're cool here. Bro, these are unique signatures. It takes a double and it takes an int. Void, do thing, int. Void, do thing, double. I'm calling those unique signatures. It is what it is. But it's creating the separate templates. Sure, it's creating different, bro, it's creating same, yeah, exactly, hold on. Instantiations, but the instantiations have different signatures, bro. I'm calling them overloads. They must be const expressions, but not necessarily. Yeah, they don't have to be const expression variables. They're just literal. They could also be literals. They just need to be const expression. Wait, hold on. Let me see. Yeah, bro. That have a specific type and must receive a const expression value. Nobody said that it had to be a variable. I just said that I could pass a variable. If I wanted to pass a variable, well, I would need to use a non-type template parameter. Oh, well, I don't know this shit yet. Compile time configuration of templates? Meaning that what, it generates some shit at compile time because it's already passed the argument at compile time, seems like? Oh, that could be kind of cool. Which are normally disallowed. Hold on. Which are normally disallowed. It's not that const expression parameters are disallowed, but function parameters are always runtime values. So you can't use them for compile time logic like static assert. And the point is because when we call a function, the parameters are runtime values, meaning that the pass happens at runtime. But if we do a template, then it is passed. Or I guess it's not even passed, but we'll say it's passed at compile time. Okay. Okay. Works for me. I gotta go to bed now.